Well, hello again. It's Chemistry B. Today's going to be day 3 of our Unit 5 topics of equations and stoichiometry, balancing equations. Now, before we get started, I want to remind you that when we balance equations, we do that to meet the universal law of conservation of mass. What this means is that mass in equals mass out. What this means is on the left side of the arrow, which is the reactant side, and the right side of the arrow, which is the product side, everything must be equal. So when an equation, when a chemical reaction takes place, whatever the mass of all of the reactants was at the beginning, by the time that reaction is all done and the products are made, though that mass will be the same thing. So when we talk about balancing equations, we have to keep in mind the law of conservation of mass. It states that, and remember that means that mass will neither be created nor destroyed by ordinary means. Okay? So when everything on the left has to balance with everything on the right, everything on the left has to have the same number as everything on the right, remember that's because of the law of conservation of mass. So let's get started. Also matter, same thing. Alright, how do we do that? How do we make the left and the right all match up? Well, first of all, we have to count the number of atoms of each element in the reactants and products. Okay, it's basically a inventory. We have to take inventory. Alright, a polyatomic ion, now remember that is a covalently bonded group of atoms that acts as a single unit, appearing unchanged on both sides of the equation, is counted as a single unit. Use a T-chart to help with the inventory. Number 2, balance the elements one at a time by using coefficients. Now, what is a coefficient? A coefficient is a small whole number that appears in front of a formula of an equation. Change that to of an equation. When no coefficient is written, we assume it to be 1. It is best to begin with an element other than hydrogen or oxygen. These two elements often occur more than twice in an equation. Key statement here. Key statement. You must not attempt to balance an equation by changing the subscripts in a chemical formula of a substance. What does that mean? Well, let's take a look at H2O. Let's say we wanted to balance something that had H2O in it. Okay, if I needed 3 hydrogens and I only had the H2O, that would give me 2 hydrogens. I'll just change that little 2 at the bottom to a 3, and that makes it H3O. That does not work. That changes the composition of the atom. H2O then becomes H3O. That is not the same thing, so we cannot do that. All right? So you cannot attempt to balance an equation by changing the subscripts in the chemical formula of a substance. That would make it very easy. Number 3, check each atom or polyatomic ion to be sure that the equation is balanced. And number 4, finally, make sure that all the coefficients are in the lowest possible ratio. What does that mean? That is the same as making sure that a fraction is in the lowest common form. So, for example, in a math class, you would get marked wrong 2/4. You would get marked wrong 2/4. Why? That's not in the lowest ratio. Remember, that would be 1/2. So just like reducing fractions, you also have to make sure the equations are balanced. Okay? Now that's a very quick overview of balancing equations. The best way to learn it is to do those problems. So we are going to do a few problems right now, and you can work through it following these rules. Okay, so the first thing that we're going to do is do what I call inventory. Okay, and we're going to make sure that we start off by listing the left side and the right side. Once again, you can see here we have a T-chart. So let's go ahead and list the elements on the left, which is the reactant side. So we'll start off with sodium, and that is Na. We have chlorine, we have beryllium, and we have fluorine. to start with, we have one sodium atom, we have one chlorine atom, we have one beryllium atom, and we have two fluorine atoms. That's on the reactant side. So now the best thing that I like to do is do the same order on the right so that it's easy to match up. So we come over here and we go Na sodium is 1, chlorine is 2, beryllium is 1, and our last one is fluorine, and it is 1. Okay? Now remember, we have to use coefficients. Those are big whole numbers that are in the front. Alright? So, let's take a look. What is already balanced? Well, we look at sodium. Sodium is already balanced on each side. Okay? Chlorine is not. Beryllium is. And fluorine is not. Okay? So, our goal is to balance those first. Alright, let's start with chlorine. We have 2 on the right side, so how can I get 2 chlorines on the left? We could put a 2 right here. Alright, now that changes the amount of chlorine we have. That also changes sodium. Okay, so we now have 2 sodiums, and we now have 2 chlorines. That matches up the chlorine again, but look what it did to sodium. That's not a problem. We'll trial and error and get it later. So let's take a look at balancing fluorine. Fluorine. Alright? On the left side we've got 2. On the right side we have 1. Here's our fluorine. To get to 2 fluorines we put a 2 here. That crosses that out. Makes it a 2. And what does it do to our sodium? I could erase it or I could cross it out either way. I probably should have just drawn an arrow through that. That makes that a 2. And double check our inventory. We got 2 and 2, 2 and 2, 1 and 1, 2 and 2. So this whole equation is balanced. Okay? Alright, now, number 2. Number 2 is a little bit more difficult. Alright? Number 2 is a little bit more difficult. Now remember the rule on polyatomic ions. This right here, these are polyatomic ions. Since there is one exactly on the left and one exactly on the right, what we can do is count those as 1. Okay? So, let's move on and let's do an inventory. Iron, oops, sorry about that. Go to this. We have iron. We have chlorine. We have beryllium again. And we have our polyatomic ion, PO4. Alright, and we're going to follow the same order over here on the the product side. And we're going to do PO4. Okay, so let's do our inventory. We have 1 iron over here. We have 3 chlorines. We have 3 berylliums. And we have 2 PO4s. Over here on the right, we have 1 iron. We have 2 chlorines. We have 1 beryllium, and we have 1 PO4. Alright? Well, let's match up the beryllium. Let's see if we can match up the beryllium here. So we'll start with beryllium. I have 3 berylliums over here, and I want to get 3 berylliums over here. So if I put a 3 here, cross that out, make that a 3. We also now change the number of chlorines. Now here's what we've got to do when we've got a subscript. The coefficient coefficient gets multiplied by the subscript. So now we have 6 chlorines because 3 times 2 is 6. Alright? So our chlorines, our berylliums are matched up, but our chlorines are not. Well, let's match up our chlorines here. Alright? We have 3 on the left and we have 6 on the right. How can I get this to 6? How can I get this right here, this chlorine, 6? Well, we know if we put a 2 there, 2 times 3 will equal 6. But look what it did to my iron. It made that 2. Alright? Now, if we go over here, let's balance out our irons. If I put a 2 there, to match that 2 here, that changes that to a 2. But look what it does. But don't forget, it affects everything after that. So it changes this PO4 from having 1 PO4 to 2 PO4s. And take a look at that. That balances the equation. Okay? Remember, you've got to use the PO4 as its own single unit. And let's do one more, and then I'll let you do 4 and 5 at home. Alright? AgNO3. So let's go AgN O Li. Well, you know what? We should probably stop that. Look what we have here. We have NO3 and we have OH and OH. So we can use those as a combination. So let's start that over again. I didn't notice that. Good. Glad I noticed that because that's going to save me some time. So I'm going to go AG, NO3, Li, and OH. AG, NO3, Li, and OH. Alright, so let's balance. How many AGs? We have 1. How many NO3s? We have 1. How many lithiums? We have 1. How many OHs? We have 1. Let's go over here. How many AGs? We have 1. How many NO3s? We have 1. How many lithiums? We have 1. And we have 1 OH. This is balanced, and that will happen sometimes. Okay? Alright, using those rules and the steps that you just saw, I would like you to go ahead and try to attempt to do 4 and 5 for class tomorrow. Thank you, and we'll talk to you tomorrow.